Hello, everyone. Today we're going to solve the Leet code question, longest common prefix. So let's go ahead and read the prompt. We're going to write a function to find the longest common prefix amongst an array of strings. So we get a vector of strings, and we just want to find what's the what are the letters that they have in common from left to right. And as soon as there's kind of a break in similarities, then that's when we no longer consider it a common prefix. So if we were to look at this test case example, we could see that actually, let's go through the simple case first. So if we were to look at these three words, we'd find that among dog, race car, and car, if we start from the left, this dog starts with a D, has no similarities with the race car. So already there's really no similarities among all these three strings. That's pretty much it. It's an empty string at that point. And then there's you kind of get disqualified here. So now let's consider this instance right here. If I were to compare flower to flow, what common prefix do they have? Well, they have flow and flow, right? So the F, the L, the O, and W. Now we wouldn't consider the E and the R because notice it stops short. So because it stopped short, because we kind of ran out of strings, or we've kind of ran out of length for our string, that means that it's not going to be a common prefix. So in this case, the ER gets cleaved. So among these two, flow is the kind of common prefix. Now, since we know that flow is the common prefix here, I can now compare flow to this. So flow compared to flight, the F is going to be the same, which makes sense. The L is going to be the same. But between flow and flight, the O and the I, that's where they differ. And so really only the FL is going to be shared between these three words. Now so this is kind of intuitive on how to think about it. So sometimes our minds are really good at kind of figuring out the pattern, but when it comes down to kind of writing an algorithm for it, it can be a little bit tricky. So the algorithm might not be as intuitive, but kind of what your brain does, the quote unquote common sense that it uses, which is not as common as you may think, it's able to kind of deduce how to find that pattern. So you could have easily kind of figured out the FL is shared between these three, and there's nothing shared between here as a common prefix. But let's look at it algorithmically. So let's consider that same test case. So this is our test case with flower, flow, and flight. One way we could do it is step one. We set up our longest prefix to be the first word. We always set it up to be the first word. So that's step one. So here it's going to be flower. Okay, simple enough. Then the next thing we want to do is we want to compare our longest prefix, whatever our longest prefix is, in this case, once again, it's going to be the first word, to each of these words. So we're going to take it one at a time. So flower is going to be compared to flower. Then whatever the longest prefix is left is going to be compared to flow. Whatever the longest prefix is left is going to be compared to flight. And so we'll take a look at it. So once again, the first word is the longest prefix. Next up, I'm going to compare flower to flower. Well, because in this case, so technically I could skip the first iteration because they're always going to match completely. So this is just kind of like a throwaway. So you could change your for loop to start at index 1 instead of index 0. I don't mind it. It's just an extra, just an extra comparison, single comparison. It's not really that big of a deal, but I mean, we could always change that if it's necessary. The next thing is we want to compare flow to flower. We just want to compare these two strings. Okay, so we're going to start off, and what we're going to do is we're going to say while both of these have length remaining, right? So while we can continue iterating through them, we're going to be able to compare them. Because say, for example, this wasn't flow, but this was just like an empty string. So it would not make any sense for me to continue because this ran out of length. And so technically there's nothing shared between them, right? The only thing shared between them is nothing. So going back to that, while they both have some length remaining, we're going to go letter by letter and compare to see if they have similarities. So here's F and F. So there it is. So we're going to go ahead and add that to a temporary string. What about L? L is shared between them. So we're going to add that to our temporary string. What about O? O is shared between them. So we're going to add that to our temporary string. W is shared between them. So we're going to add that to our temporary string. And then the last thing is, in this case, now the loop, right? The loop ran out because we ran out of length here. We still have length remaining here, but we don't have any length here. So that's it. So now this temp is our new longest prefix. What I'm going to do is I'm going to go ahead and replace longest prefix with flow. And I'm going to reset this back to nothing. Next up is we finished these two iterations. Let's go to the next iteration. So we're comparing the longest prefix to flight. So once again, starting from the first letter, F and F are the same. Then LL are the same. And then we notice O and I are no longer the same. And so because there's a dissimilarity, right, they're no longer equivalent, we're just going to go ahead and break out of it. You don't want to continue with your loop and maybe find another possibility. As soon as there's some kind of difference, you break out of it. That was the longest prefix. So I really hope that made sense. If you have any questions, or I should say, if you still don't feel comfortable with it, I strongly recommend watching this video or watching this section of it a few times. I always say it's very, very important to understand what the question is asking. And once you understand the logic behind it, coding it becomes much simpler. Now, another thing to consider is this works because the constraint is between, the number of strings that I have in my vector is between 1 and 200. So I can always set my longest prefix to the first word. So we don't have to worry about that edge case, right? And then we can have an empty string up to 200 letters and then consist of only lowercase English letters. Okay, that's perfectly normal. So let's continue. So what do we want to be able to do? This is going to be our function that is going to perform these comparisons. But notice we're going to perform a lot of comparisons between two strings. We're going to have this string, which is going to be the longest prefix, or the current longest prefix. And then this string, which is the comparison, right? This is the one we're going to compare it to. So we're always going to compare two strings at a time. It would be nice to kind of create a function ahead of time, which would always give us back the longest prefix given two strings. So given two strings that I enter, it'll give me back the longest prefix. So you can imagine, like, if I had something called longest common prefix. So I'm going to overload our existing function. So not just this one is with our actual vector, but here I'm going to overload it to take in two strings. So I'm going to take in kind of like, let's say, for example, the current longest prefix. And then I'm going to take in the comparison, which is the next word. So you can imagine the current longest prefix is, let's say, for example, flow. And then the comparison was flight, exactly how we compared it just recently here. And then what this will evaluate to is we can have it return the FL, we can have it return the longest prefix between them. Or what we can do is we can have this passed by reference, and then we can just update this, whichever one feels more comfortable. I'm just going to go ahead and set it by reference. So whatever the current longest prefix is, we're going to do that comparison. We're going to stick it in temp. And then the last thing we're going to do is we're going to overwrite our longest prefix with the temp. Okay, so once again, in this case, we're not going to return anything. It's just going to be a void function. And that's because we're going to use references. So here, we're going to have void function. It's going to be called longest common prefix. And it's going to take in two strings. So it's going to take in the string reference, which is going to be our current largest prefix. So this is going to be our current largest prefix. And next up is our comparison. So this is going to be the word that we're going to compare it to. So I could call it, let's say, compared string. So once again, in this instance, we're just comparing two strings, and I would just want to find the largest common prefix between the two. So let's go ahead and create our string temp. This is where we're going to put that result in, what the next longest prefix is. And we're also going to iterate through both of these strings. Now, what was the condition? We iterate through both of these strings while they still have characters remaining, while there's still some length left to them. So what we're going to do is we're going to say for int I equals 0, I is less than my current largest prefix dot size, and I is less than my compared string dot size. So as long as there's length remaining between the two, then I'll continue iterating. Next up, what we want to do is we want to check for similarities. So if there are similarities between the two, so if current largest prefix at the index I matches the compared string at the index I. So if we do find a match, like in the sense that, like, for example, we had the F matching with the F, what do we want to do? We want to add that to our temporary. So we're going to go ahead and add to our temp. Either one of these will do because they're the same letter. So it doesn't really matter which one we pick. I'll just pick the first one since that's closest. That's fine. Now, if it matches, we add it to our temp. If it doesn't match, then what do we do? Well, in that case, it's no longer a common prefix. We don't want to consider anymore. We don't want to add any more to our temp, just because once we found a dissimilarity, there's no going back. There's no kind of dissimilarity and then finding a similarity. It's just as long as they're similar, we continue, and then whenever there's a dissimilarity, that breaks the sequence, right? So we cut it off there. So we could say if there is no match between them, right? If we find a case where they don't match, we break out of this loop and we're done. So at this point, temp has the new current largest, or the new largest prefix. Now, if I was returning a string, then we could go ahead and just return the string at this point, return temp. But I'm passing by reference just to be able to kind of, I guess, save some memory. I'm not sure if behind the scenes it would have been already optimized, but I mean, we're just passing strings by references. That's always good practice. So we're gonna update our current largest prefix with temp. Now, current largest prefix is our new current largest prefix, and we're gonna go ahead and return that value. Okay, great. So now we have this overloaded function, which is gonna help us return the largest prefix between two values. So now let's go to our actual problem. So what are we gonna do? We're gonna set up the largest prefix, longest prefix. I feel like I'm gonna have some syntax errors here. I'll run it just to double check afterwards. And what do we want our longest prefix to be? What did we say we start off with it being? It's gonna be the first element, right? The first string within our vector. So we're gonna go ahead and set that to our element at index 0, right? Or string at index 0. Now, the next thing is, now that we have our longest prefix, we're going to use this function to essentially go through our entire list, and compare our longest prefix with each of these words. So it's going to compare this longest prefix with the first word, this longest prefix with the second word, this longest prefix with the third word, and so forth and so forth. And remember, each time within here, it's going to update what the longest prefix is. So at some point, it might get shorter and shorter. It's likely going to get shorter. It doesn't get longer. So what we're going to do is we're going to iterate through our vector. So here is going to be our vector. Let's see, auto ref is a word. And I'm going to go ahead and go through my container. And what I'm going to do is, since it's a void function, I don't give anything back. I'm going to call this function with my two inputs. The first input is going to be the largest prefix, or the longest prefix. Once again, this is passed by reference, so it's going to get updated inside of here. And then what am I comparing it to? I'm comparing it to the word, right? So that's pretty much it. I'm just comparing it to that value. And for each iteration, it's going to go ahead and narrow it down and get the common largest common prefix. Once that's done, we know that longest prefix is, we know that at this point, longest prefix is the actual longest prefix. So now all we need to do is return that longest prefix. Okay, cool. Let's go ahead and run this. Hope I didn't make any syntax errors. Yeah, so I feel like I kind of went between these words quite a bit. Current largest prefix. Should not return a value. Oh, yes. Sorry. What am I doing? Why am I returning a value? This is a void function. So there we go. So apologize. We shouldn't be returning anything because, once again, this is a void function. We're passing it by reference. So we're updating it within the scope of this function. So let's go ahead and run it once more. And let's take a look. Okay, looks good. So everything looks good. It's a working solution. I hope that this made sense. Please let me know if you have any questions. Um, feel free to comment down below and I'll do my best to answer any questions. I also want to say that I'm not able to share code within within these problems just because within the description, it doesn't allow me to share code due to probably like code injections. So I hope you enjoyed this video. Thank you so much for watching, and I hope you have a wonderful day.